Consequences of multicollinearity. So before this, we discussed about perfect multicollinearity and imperfect multicollinearity. And we know that if we have perfect multicollinearity, the coefficient can be determined, and also the standard error will be infinite. And then we learned that when we have imperfect multicollinearity, the coefficient can be determined. But then we need also to understand what is the consequences of having imperfect multicollinearity. So even though OLS estimators can be determined, it will have large variance and also covariance, meaning that when you have estimators with large variance, the estimation is less accurate. So when you have a large variance and a large standard error, it will affect the confidence interval. So the estimation confidence interval will be wider, because if you look back to the formula of confidence interval, it is beta 2 hat, example beta 2 hat plus minus the critical value, the t alpha over 2 degrees of freedom multiplied with the standard error. So you're going to have plus minus a bigger standard error, so it will lead to a wider confidence interval. So when you have a wider confidence interval, so meaning that your acceptance region will be wider, and this will lead to the acceptance of null hypothesis, meaning that you are unable to reject the null hypothesis. So because of that, the t-stats of the coefficient tend to be statistically insignificant, because we know that when we say that the t-stats is significant, meaning that when we say findings is significant, meaning that we are rejecting the null hypothesis. So since we are unable to reject null hypothesis, so the t-stats here tend to be statistically insignificant. But besides that, R squared can be very high. So we like R squared to be high, but then at the same time, very few or non-significant t statistic. So this does not fit. So we want R squared high and also a lot of significant t stats. So here, in case of multicollinearity, one of the detection is that when you have a high R squared but then few or non-significant t statistic. At the same time, OLS estimators and their standard errors can be very sensitive to small changes in the data. So if you change the data by a little bit amount, the OLS estimator and the standard errors will change a lot in terms of the sign or in terms of the significance. On the other hand, the OLS estimators are still blue, best linear unbiased estimator, because when we have imperfect multicollinearity, actually we do not violate the CLRM assumptions, because the CLRM assumption saying that no perfect collinearity. It doesn't say no imperfect multicollinearity. So here, if we have imperfect multicollinearity, meaning that we are not violating the CLRM assumption, therefore we are still fulfilling the CRM assumption, therefore the OLS estimator are still best linear unbiased estimator. And the overall fit of the regression equation will be largely unaffected by the multicollinearity, meaning that if we want to do forecasting or prediction, we can do that because it is largely unaffected. The only effect is the precision or the accuracy of the OLS estimators. So why OLS estimators are still blue under imperfect multicollinearity? So we talk about unbiasedness. Okay, so unbiasedness is that expected value of beta 2 hat is going to be equals to beta 2. So it is referring to a repeated sampling property, meaning that if we have 100 research and we having same sample size of 100 and we are doing it repeated sampling, so meaning for each regression we have this beta 2 hat, and we have found that the mean of those beta 2 hat will be same as beta 2, the population parameter. So since unbiasedness is a repeated sampling property and not the properties of the estimators in any given sample, therefore the OLS estimators are still blue. And minimum variance does not mean small variance. So meaning that we have the minimum variance, but it doesn't means that the value of the variance must be small. Therefore, imperfect multicollinearity is essentially a sample phenomenon. So according to Commental, 1971, when we talk about multicollinearity, it's just a question of the degree, not the problem of multicollinearity. So we want to know, is it a very high degree of multicollinearity, or just simply because eventually we will have the problem of multicollinearity, but the question is the degree of the multicollinearity.